Okay, Prez, day 11. Here's my dog, Annie. Look, Annie, look. Treat, treat, treat. Over here. Say hello. Hello, presentation. This is Annie. She's excited. Anyway, so we're going to talk day 11. We're going to talk about monomials, polynomials, adding polynomials, zero product property, and GCF of monomials. My dog, look at her. She wants to look outside the window. There's something going on out there. All right, let's hit it. Lots of examples today. A little bit of explanation, but mostly all examples and a few definitions. We're going to start with some definitions so we really get this. So we're going to start off with monomials. These are a number like 2 or 3 or -10, or a variable, and it could be a number, could be 3/2, could be fractions number, and then multiply by a variable, or a variable with a positive exponent, x to the first, x cubed, y squared, positive exponent, no zeros, right? Positive exponents. So, no zero or neg exponents, or product of a number and one or more variables with positive exponents. Okay, so it can be either one of these, or any combination of them all multiplied together. So that's a monomial. So let's see, which of these are monomials out of these, these 6 things? What are monomials, right? So you can have one, the other, or them multiplied together. Okay. Yeah, so this is, so I want you to pause and try. That's what P and T means. Pause and try. P and T. So, hope you're back. So this -1, this is, because this is a number, right? This is a number. X squared, yep, this is, because it's a variable with positive exponent. Is this? And this is, this third one is, because we have things all multiplied together. That's a product of a number and one or more variables with positive exponents. So this is a number. You can have fractions. Fractions for coefficients are okay. But, and then this has a implied coefficient of 1 and a coefficient, or sorry, exponent of 1. And this has an exponent of 2. So they're positive exponents. So that is. This one here is not. -1, no. Because you can't have a negative exponent. No. How about x to the a? Well, this is no, because we don't know what a is. A could be negative, a could be a fraction, so this is no. X plus y, how about that? Well, that's no. That's not a monomial. That's not a monomial, because you got two. This is a monomial and this is a monomial, but when you add 2 monomials together, you get a binomial. You don't get a monomial. So this is no. Okay, so that's monomials. Hopefully you got it. How about this one? 1 over x squared. And this is no. This is no. Because you can't have, you can't have exponent in a fraction, in denominator. Again, so we're talking about monomials. This is kind of a new thing. In the last section, we talked about 1 over x squared being okay, but now that we talk about monomials and polynomials, you can only have your squareds in your variables in the numerator. Okay, so now let's talk about the degree of a monomial. A degree of a monomial is the sum. You just take all the exponents of the variables, So a limit, forget about your coefficient and just add up all the exponents of variables. This is pretty straightforward. So what is the degree of these guys? The degree of this one is 3. because that's just a 3. The degree of this is a 2. We forget about the 4. We just look at the variables. So we add that up, 2. And this one here, the degree, we forget about the coefficient. And we say, well, we have a 1 plus 2, so this has a degree of 3. You add your exponents. It's the sum of all of them. So it's your x and your y and your z and all of your exponents. Now, how about this one? What's the degree of x? The degree of x is 1. And how about the degree of the number 4? Well, we have no exponents. So we have a degree of 0. There's no exponents here. All right, a polynomial is now, this is when you take a monomial and you take the sum of one or more. So let's just look at that real quick. So we have an example. We have examples here of, these are all examples of monomials. Let's switch to green just for a second. So if we add one or more of these together, we get a polynomial. So these are polynomials. You add one or more together. This, how about this? Yep, that's a polynomial. That's a very simple polynomial. It's also a monomial. This is a polynomial. Poly means one or more, right? And so, but this is specifically a binomial, because you have the like bicycle has 2 wheels. This is a binomial. What do you think this is called? This is a polynomial, also called a trinomial. Right, so you can add one or more together. 1 is a monomial, 2 is a binomial, 3 is a trinomial, et cetera, et cetera. Okay, now let's get into some examples. This is what you all want and have been waiting for. So I'm sorry to have bored you with some definitions, but let's move on. Okay, now we got to talk about like terms. So now I'm going to ask you some questions. These are like practice problems. Which of these are like terms? Like terms are terms that have the same variables with the same exponents, and you ignore the coefficients. Ignore the coefficients. So we got to look at these. Are these the same variable and the same exponents? I want you to make a decision about all 7 of these. So I want you to pause and try. Okay, let's go forward. You've paused and tried. Now you're back. This is no, because these have different exponents. This is a 1. This is a 2. Not equal, so this is no. 2x and x. We ignore our coefficients. So we ignore our coefficients. We just circle our variables. And so these are yes. These are exactly the same. Similarly, here we ignore our exponents and we look only at our variables. Are those exact matches? These are exact matches. A squared, b squared, a squared, b squared. So this is a yes. No. Yes. Only look, doesn't matter if this is negative, we only look at our exponents, and so these are a yes. These are the same. Here, just circle our exponents. X, Y, Z can have more than one exponent, or sorry, more than one variable as long as they all have the same exponent, so this is yes. Yes. How about this guy? And they have all the same variables, but different exponents. Here we have a b squared, and here we just have a b. So this is no. These are not. These are not like terms. We cannot add them. And how about 7 and negative 21? Well, yes. All constants are like terms. Right? Because they don't have any, there's no variables. So you can add these together. So the idea, again, if like terms, you have to have like terms to add or subtract. Must have like terms to add or subtract. Now we're going to do examples of adding or subtracting. Okay. Adding and subtracting like terms. I'm going to circle and box like terms. So this is a like term and this is a like term because they exact matches. And this is a like term to this. So we combine these and we get 8a minus 6 because we can combine these by adding the coefficients and we add numbers just by adding numbers. Here, I'm going to box my like terms. And notice if I box, in my box include this, the sign or the operator. Because that allows you to easily combine these. So now let's circle our constant terms. And x squared is its own like term. So I'll put a little wavy line around that one. So now this is going to be, well, x squared is by itself. 10 and 4 is 14 x's. 12 and 9 is 21. And notice, I order them. If you write, when writing polynomials, I'm going to call them polys. When writing polys, order by degree. Remember our degree. This is a degree of 2. This is a degree of 1, and this is a degree of 0. All right. C. So this is a like term. Now what else matches AB is this one. We're going to circle our A's. And our B will just do a little tick, 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 tick. All right, in degree, this has the highest degree, our ABs, so we put them first. 13AB. Our A's are next, so that's 5 A's. And then we're going to subtract our 6 B's. Now these both have a degree of 1. This has a degree of 2. That's why I ordered them like this. And I put my A first, alphabetical. Right, A is alphabetically before B. All right. Next one. Oh no. We have to remove our parentheses. We can't just add these without get rid of parens and the operator, our negative sign. We have to get rid of that first. So we have 4a minus 2b minus 2a, and this negative distributes and gets rid of that one. Right? This was like a negative plus, and this was a minus minus. So this is negative 2a because these combine to make a negative. This negative and this negative combine to make a positive. Okay, now we can box our A's, circle our B's, and we get 2a plus b. Similar here, we can just drop these. This is like a positive, so we can just drop our parens. But this one here, we subtract, and we subtract b. And here we get our A's and our B's. Well, a minus a is 0. B minus b is 0, so our answer is just 0. All right, down here, let's box our x squareds. I love this boxing and doing shapes. It really makes the math easy. Circle our xy terms, and then we'll squiggle our y terms. Okay, our x terms, we get negative x squared. Notice all of these have degree of 2. So alphabetically, x times x comes before xy, which comes before y squared. So now we do our xy terms. This is 1xy, that's another xy, so that's 2xy, and our y squareds cancel. Y squared minus y squared is 0. So there we go, adding and subtracting. Do we have more adding and subtracting? No, now we have multiplying polynomials. Now, multiplying polynomials, you just got to remember distribution. In some cases. We don't always distribute, but we're going to remember distribution in some cases. Here, this is just a monomial times a monomial. We did this. This goes back to lesson 8 and 9, right? Here we just multiply our coefficients, and then we add our exponents. Right? We have an x term. X times x squared is x cubed, and then y squared times y is y cubed. Okay, here we have to distribute. And here all we have, don't confuse this. This is just 3 multiply problems. This is 3 multiplications. It's negative 2a times positive a squared times positive ab and times negative 3b squared. And so we're just going to do something like this, but we have to do it 3 times and get our signs right. So negative 2a times a squared is negative 2a cubed. A times a squared, negative 2a cubed. And we get negative 2a times ab is 2a squared b. And then negative 2a times negative 3b is a positive 6ab squared. C, 2x squared, 2x times x is 2x squared, 2x times x squared is 2x cubed, and then we have 2x to the 4th. And then we rewrite that in descending order of degree. So that's easy. Now we get into this situation. Remember, this is called foiling because we're multiplying a binomial by a binomial. And so that's first outside, inside, last. So we get a squared minus 3a plus 2a minus 6, right? A times a squared is a times a is a squared. A times negative 3 is negative 3a. 2 times a is positive 2a. Positive 2 times negative 3 is negative 6. And then we got to combine like terms. Once we start doing this polynomial times polynomial thing, you're almost always going to be combining terms at some point. Almost always. Okay, negative 3a plus 2a, negative a. First, outside, inside, last. 6a squared outside plus 2a inside negative 21a last negative 7. So that's 6a squared minus 19a minus 7. Okay, first, outside, inside, last. 9a squared, outside, minus 6a, inside, plus 6a. Whoa, this is going to be cool. Minus 4. Oh, what do we get? The middle ones cancel out. And so we get 9a squared minus 4. We're going to learn something special about this pattern later on when you get that middle canceling. There's something special about how this is written, about this multiplication of binomials that makes that middle disappear. Maybe you can see it, or maybe you learned this before. Okay, let's keep going. Now sometimes you got a binomial times a trinomial. This is going to be 6 multiplications. You're going to have the first one times these 3, times all 3, and then the second one times all 3. So just if you have 2 terms and then you have 3, a trinomial, you're going to end up with 6 multiplications, just so you know. We're going to do this one via the long multiplication method, and then we're also going to do it via the box method. Okay, so if we do the first times this thing, it's going to be, well, let's do it in, let's do it in green. So we get a cubed minus 3a squared plus 5a. And then the second one, we get plus 2a squared minus 6a plus 10. Now we got to combine like terms. So there's only one a cubed term. Let's do the ones that are alike. So we're going to box this one and box this one. And then we're going to circle this one and circle this one because they're like terms. And then these are my ones that are left over. So I'll just rewrite a cubed, and then I'll put my squared terms next because that's the second order or second degree. So that's minus a squared. Combine my a's, which is minus a, and then plus 10. All right. Good. Okay, now we're going to do this using the box method. I could have done this using the box method, and that looks like this. I say a plus 2. I write my terms on one side of a box, and then I write my other terms on the other side of the box, and I just do all my multiplication like this. Plus 5. See what I've done? I've just basically taken my a plus 2 and put my a and then plus 2 here. And then up here, I put my a squared, my minus 3, and my plus 5. And then I get a cubed minus 3a squared, and then 5a. Here I get 2a squared, negative 6a, and then 10. I just multiply this by this to get this by this to get this, a by plus 5. See, I multiply, and I multiply that into every box, and then I see which terms need to be combined, and I usually can circle them. They usually end up on diagonals. So I get a cubed, this becomes minus a squared, this becomes minus a, and this becomes plus 10. Okay, I'm not sure. Whichever version you like, you can use it. Now we're going to do zero product property. So this says if two numbers multiplied together is 0, then one of the numbers has to be 0. There's no two numbers multiplied together that gives you 0 unless one of them is 0. And that's really powerful. It sounds obvious, but it's really powerful. So if x is 10, then y must be 0. There's nothing times 10 that equals 0 other than 0. And so if you can think of any number for x, it's not 0, y must be 0. Similarly, if y is any number that's not 0, then x must be 0. So that's the zero product property. So how do we use that? Well, if we see this, then we know what's true. If two things are multiplied together, x minus 3 times x plus 2, then this must be 0 or this must be 0. So the way we write this out is x minus 3 equals 0 or x plus 2 equals 0. Well, if x minus 3 is 0, then x equals 3 or x minus 2, x equals minus 2, right? Subtract 2. So x equals 3 or x equals minus 2. When we write that like this, x equals minus 2 or 3. Doesn't equal and, it equals either or. This means or. This is also called set notation. These are the numbers that make this thing true. All right, let's just keep going. So this is, well, two things multiplied together. This first thing, x equals 0 or x minus 4 equals 0. So this is x equals 4 or x is 0. So we write this like this. A very common mistake is that students will say, oh, well, x equals minus 3 or x equals minus 2. or x equals positive 2. And that's wrong. You can't do that. It's going to be negative 2 or 3, not negative 3 or 2. So be careful. So this is x equals 1, or you can do it 3 times like we do here, or x minus 2. Let's just write this one out. We're going to write this one out, then we'll go shorthand on the next one. Or x minus 2 equals 0, or x minus 3 equals 0. Well, this is x equals 1, or x equals 2, or x equals 3. So you write that. You can write all three things in set notation. Here, 2x equals 0, which is just x equals 0. Now here we have a tricky one, so don't screw this one up either. So 2x plus 1 equals 0. That's 2x equals negative 1, so x equals negative 1/2. That's an or. Or x minus 4 equals 0, which is x equals 4. So write these in numerical order. X equals negative 1/2, comma 0, comma 4. And finally, we got, well, 7 equals 0. Well, that's never true, so who cares? A minus 1 equals 0, or b minus 2 equals 0. So here we have a equals 1, or b equals 2. So we write it like this. We can't write that in set notation because you can't, because this one says a and this one is b. So that's two different variables. Okay. All right, that's the zero product property. Now we're going to end up with doing GCFs. So we're going to do 6 GCF problems, 4 on this page, 2 on the next, and then be done. Now the way that we do GCFs, you got to be careful and be precise. I'm going to do it. This might be overkill for you, but you'll never make a mistake if you use this method. So we're going to write our monomials here that we're trying to find our factors in. And notice, or our GCF of. GCF stands for, greatest, this, because this is like you did this in 6th grade, I think. Greatest common factor, but you never did it with variables. So we're going to start off by doing it with numbers. So what are my factors of 24? Well, it's 2 plus 2 times 2 times 2 times 3. Write them in, and write these in increasing order. And this is 2 times 3 times 3. So now what we do is we circle the common factors, 1 for every match. So we don't circle all of our 2's. We only have 1 2 that matches. And then we don't have any more 2's that match. So now we have 3's, and we only have 1 3 that matches. So our GCF now is these two numbers multiplied together. So that's 6. And here GCF is always the same. And now what's left over is 2 times 2, or 4. And this is a 3. Now, this is the answer we're looking for, the GCF. So that's a 6. These leftovers become important later on. So let's just make those part of the chart that we're using. Okay, so now let's move on. So now let's do this with the GCF of these two monomials. So we're going to copy those out here. And we go 2 times 2 times 3 times A times B times B times B. And here we got 2 times 2 times 2 times 3 times A times A times A times B times B. So here we have, let me circle this in a different color just so we don't get lost. 2, 2. We only do the same number that matches. 2 and 2. 3 and 3. Then we have 1A that matches. We only have 1A. We do the same thing with variables that we do with our other factors. There's 1A that matches, and then 2 B's that match. So our GCF now is 2 times 2 times 3, which is 12. A, b squared. 12ab squared. And my leftover on top is really just a b. That's the only thing left over. And on bottom, we have a 2. A times a is a squared b. So my GCF, these leftovers, again, become important later on. So we're going to always write those out. And our GCF is 12ab squared. All right, now we got to deal with negatives. So let's learn about negatives and how we deal with that. So we know how to write our monomials here. Our factors are 5 times x times x times y. Now, if you ever have a negative, with a negative, you always put a -1 in front. And now we just pretend, so if a negative means we always put a -1 first, and then we just factor it as if it was a normal positive monomial. Okay, so our GCF here, what matches is our 5. The -1 doesn't match a -1 on top. So we have our 5, we have 1x, and we have 1y. So our GCF is 5xy with a leftover of x on top. And then on the bottom, we have -1 times -2 is -2y. Here we got -9ab, and on the bottom is -15a squared b squared. So we have -1 times 3 times 3 times a times b, and on the bottom we have -1 times 3 times 5 times a times a times b times b. So our -1s match. We have 1 3 that matches. We have 1 a that matches and 1 b that matches. -3ab, -3ab, and our leftovers on top are 3, and on bottom it's 5ab. So our GCF is -3ab, right? A GCF will only be negative if everything's negative. Otherwise, you won't have your matching -1s. Okay, one more page, 2 more GCFs, and then we're done. All right, we're going to do GCFs of 3. And the thing here, if you guess, you have to have, everything has to match. It's not 2 matching. It's all 3 have to match. So let's see how that works. So I have to have 3. So we have a 3 that matches on all of them. No other numbers match. They all have an A, and they all have 1 B. Now this one's going to bring up an interesting case here on the bottom because we don't have anything left over. So, but our GCF is 3AB. And on top, so we have our leftovers is 2B, -3A. And because we don't have anything left, if we divide 3AB by 3AB, we get 1. Our leftover is not 0. It's not a 0. If everything's gone from our factors and we have our GCF, it's the same as our monomial. What's left over is a 1 when we divide the monomial by our GCF. It's not a 0. This is important. This is super, super important. Okay, let's move on. -5x cubed y squared, -15x squared y to the 4th. Hopefully we have enough room. -20x cubed y cubed. Okay, -1 times 5 times x times x times x times y times y. -1 times 3 times 5 times x times x times y times y times y times y. This is going to be tricky. -1 times 2 times 2 times 5 times x times x times x times y times y times y. Let's circle in a different color. All of them have a -1. All of them have a 5. And all of them have 2 x's. And all of them have 2 y's. So our GCF is -5 x squared y squared. So our GCF is -5 x squared y squared. And I'm going to write my leftovers because that's important for where we're going later. And so this here, it's just an x is our leftover. Here our leftover is a 3y squared. And here our leftover is 4xy. And there you have it. There is, there is day 11. Is this day 11? Yeah, day 11. Day 11 is now in the books. My dog is asleep. You have what you need for getting ready for day 12 quiz. And we're almost done with this year. I think there's one more big lesson, maybe a little bit of learning on day 13, but mostly day 12, and that'll be it. And then you'll be ready for your midterm / first 3-week final. All right. Good talking to you soon, class.